Well, hello geometry. It is November 9th. There's some snow outside. I walked the dog. She went crazy and loved it. But I'm over that. So here we go, 5.4. Hoping I can get this video done before I have to go to class today. I can use medians and altitudes. So we have two different lines in this section to solve problems like finding distance relationships. And I can find the centroid, the median, and the orthocenter, which is the altitude, goes with the altitude. So those for those concurrent points. All right, so a little bit of review here. Let's start. We have 2 points. Find the midpoint. Remember, you take the two x values, add them up. -4 plus 5 divided by 2, and then take the two y values, add them up. Okay, it's kind of, why can't we see that? Maybe with all the snow outside, I don't need this light on above me. I don't know. In any case, when I add this up, I get 1/2. And then when I add it up, 16/2, that's 8. Again, start using your programs for these. Find the length of these 2 points for AB. So the distance of AB is the square root. Remember, you take the two x values, take the difference of them, and then take the two y values and take the difference. -3, wow, I really can't see this. -3 plus 4 is 1. When you square it, you still get 1. Sorry, -3. Why did I put plus 4? Minus 4 is -7. When you square it, you get 49. And then negative is a positive, so we get a 3 here. Square it, you get 9. 49 plus 9, that's going to be the square root of 58. I'm okay with that, but if you really want to know that distance, it's about 7.6158. Let me try to turn this light off, see if that helps. Now it looks blue. I don't know what to do. Okay. Not sure why it's get crazy glares in this room. All right. How about this one? A is equal to 0,4. C is 18,4. Find the length of AB, where B is the point that's 2/3 the distance from A to C. Okay. So let's see here. Let me draw a little picture on the side. Hopefully you can see this. At 0,4 we have A, and then at 18,4 we have C. So this whole distance is 18. Okay? Wow, this is kind of disturbing here. I'm not sure why I can't see that. We'll try our best. So this distance is 18. I need to find 2/3 of that. So 2/3 of 18. Remember, of means multiply. So 3 goes in 18 6 times. Times 2 is 12. So I need that distance to be 12. So where is B going to be located? 12, 4. Pretty cool. All right, 2/3 is important here. Okay, that's definitely going to come up in a little bit. Vocabulary. So the triangle will balance at a particular point. This point is the intersection of medians. Okay, so the median of a triangle is a segment from a vertex to the midpoint of the opposite side. The three medians of a triangle are concurrent. The point of concurrency is called the centroid. Okay, so basically if you find the three medians, it's called the centroid. Put a pencil tip right there and see where they meet. It'll balance. Okay. Sorry, it's the phone. Not sure who that is. All right, moving on. Theorems. Concurrency of medians of a triangle. So this is where our 2/3 come into place. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So if you look at PV, That is this segment right here. Here, let's maybe make that red. Of course, now you can't see it because I went over it in black first. This is 2/3 of the whole length, PT. QV is 2/3 of the whole length, QU. And RV is 2/3 of the whole length, RS. So this is actually really important. Okay, now I gotta do that in black. Please remember this. If I had a highlighter, I would highlight this. But for some reason, it's missing. Okay, all right, here we go. Let's start playing around with that. Use the centroid of a triangle. In triangle ABC, M is the centroid. AM is 12. Find MF and AF. Okay, so, well, remember, 2/3 of AF, of the whole thing, is equal to AM. And we know that AM is 12. So 2/3, I'm just going to call that X, is equal to 12. How do you get rid of a fraction? Multiply by the reciprocal. X is equal to 2 goes into 12 6 times 3, we get 18. So that means AF, the whole length is 18. If this whole length is 18, how long is MF? That would be 6. So that's how that works. Pretty cool, huh? Not really sure why I put all the work there when I should have put it here. Now, does AM equal CM? Not always. If you had an equilateral triangle, however, is it equilateral or equilateral? I don't remember. Okay, can the centroid and the incenter be in the same point? Also sometimes. Again, equilateral. So you also have other things going on with isosceles triangles, but equilateral is quite special. All right. Example 2. The vertices of triangle ABC are A, 1, 5. B is 5, 4. C is 5, 5. I'm not sure why I'm plugging all these. Oh, shoot. 1, 5, 5, 7. Darn it. There's our B. C is 9, 3. I'm like, why does my picture look different? Okay, so I'm going to connect those. Should have read the question first to see what they're doing. All right, which pair gives a coordinate of the centroid? All right, here we go. So 5, 4 is right here. That is not a centroid because it's not inside the triangle. So we can definitely cross that one out. 3, 6. Go over 3, up 6. That's not going to be one either. All right, those could be midpoints though, right? These could be midpoints of the sides. 5, 5 could be. And then 7, 5. No. Okay. Now what's interesting about all those points there, these look like they're midpoints of each one of them. And if I were to connect, I think this is kind of cool because all the answer choices, or 3 of the answer choices, turn out to be midpoints. And they will cross at this point 5, 5, which is the median. Okay. Of course, we would have to find this distance, which we can go ahead, and then do 2/3 of that. Now, I actually went ahead and did the work prior. I don't know if you want to pause this. Let's see if I can get the glare out. It doesn't seem like it. So here's the work for it. I found the midpoint of each side. and it did happen to turn out to be those those ordered pairs. And when you connect them, they all hit your centroid. So when you connect the midpoint to the opposite sides. So why don't you pause this and copy this down, and we'll go on to the next page. Yeah, I'm trying to save up a little time here because I'm a little nervous about being late for class if I'm still on this video. Alrighty. Here we go. Vocabulary. The altitude of a triangle is the perpendicular segment from the vertex to the opposite side that contains the opposite side. So here the altitude makes a perpendicular line, but it goes from the vertex to the opposite side. If you have a right triangle, it's going to be on the leg of that right triangle. If you have an obtuse triangle, notice how you have to extend this side and your altitude is going to come outside. So you could get a bunch of altitudes outside your triangle. The concurrency, let's see here. These are all your altitudes. I'm going to say the red lines are altitudes. If you could, well, you won't be able to see the red lines. I guess can you see it in the video? Red lines are altitudes. But on your, obviously your notes, it's not red. Maybe you should highlight that. Okay, so concurrency of altitudes of a triangle. The lines containing an altitude of a triangle are concurrent at a point called the orthocenter. Okay, so if we look, notice we had to, if I want to find the altitude, we have to extend this side. Let's see, this one, if I extend this side right there, and then if I extend this side right here. So I have two altitudes outside of the triangle because it's an obtuse triangle, so it gets kind of crazy. So the orthocenter meets way out here. But when you have an acute triangle, they all meet in the center. I kind of like that. It's a little bit more fun. The orthocenter may be located outside the triangle as shown in the picture on the left. Okay, so show the orthocenter can be inside, on, or outside of the triangle. Obviously, you have these three pictures right there. So again, to shorten up time, I'm going to put up my other example, and I want you to pause it and copy it. So if you use an acute, a right, and obtuse triangle, let's see here. I tried to use colored pens. Not sure how well that worked, but with an acute triangle, notice the three perpendicular distances from the vertex to the opposite side, not distances, perpendicular lines, will meet inside. Okay, so if you have an acute triangle, the orthocenter is inside. If you have a right triangle, the orthocenter is on the triangle. Okay, and then if you have an obtuse, notice how these meet way out there. So this one gets kind of tricky for people. We can practice that in class if you'd like. So copy this down, and you might need to pause this. Last page. This is cool info. I hope you find it cool. Okay. In an isosceles triangle, the perpendicular bisector, the angle bisector, the median, and altitude from the vertex to the base are all on the same segment. In an equilateral triangle, this is true for the special segment of any vertex. Okay, so basically, I used construction. You know what, I'm just going to go ahead and do this again. I used construction and found the perpendicular bisector, and this also cuts this in half. Oh, geez. Yeah, it might be part of it. Yeah, it's kind of hard to see the construction part because it's lightly done in pencil. But this angle bisector is also perpendicular bisector. It's your median and an altitude. It's all on the same line. But if you were to go to find from all 3 points, you'll see that they'll be on that line. When you have an equilateral triangle, if you find all of them, I did construct it. The circumcenter, the incenter, the centroid, and the orthocenter are all at the same point. How cool is that? Okay, so equilateral triangle is kind of easy. You just find one of them and you have all of them. And now we're going to do a proof. We'll finish it up. Okay, so triangle ABC with AD is an angle bisector and an altitude. Okay, so if you have an angle bisector, it's going to cut this angle in half, and it's an altitude, so that means we have a right angle. Okay, let's prove that this is isosceles. So I'm going to start with all of our given information. I have to write really small here to get that in. Triangle ABC with AD is an angle bisector, and altitude to BC. That's given. All right, so that's always nice to do. All right, so now triangle BAD and angle BAD and angle CAD. And then we also have BC is perpendicular AD. So what does an angle bisector do? It says these two are congruent, so I have to list that. So angle BAD is congruent to angle CAD. And then also this tells us I have two perpendicular lines. So BC is perpendicular to AD. Why? Definition of angle bisector and altitude. Yeah, I got a little lazy. Put them in the same one. Okay, now then we have angle ADB and is congruent to ADC. Okay, so if we have if I have a perpendicular lines, I have two right angles. So, and then I'm also going to say they're right angles. I'm going to put two things together. Angle ADB, that's this one right here, is congruent to angle ADC, and they're right angles. So definition of perpendicular lines. Then we use my reflexive statement. AD is congruent to AD. Okay, remember what we're trying to do. We're trying to prove that this is isosceles. How do you know if they're isosceles? You have to have two base angles that are congruent and two side lengths, opposite sides that are congruent. So now, what I'm going to do is I'm going to say that this triangle is congruent to this one. So triangle ADB is congruent to triangle ADC by angle, side, angle. Okay, you're like, wow, we ran out of statements. For some reason, I don't have enough lines here. So number 6. Now, if I know the triangles are congruent, then I know that this angle is congruent to this one, and I know that this side is congruent to that side. So I'm going to write all of that out. Angle B is congruent to angle C, and then AB is congruent to AC. That's by CPCTC. Corresponding parts of congruent triangles are congruent. And then last but not least, if you know the base angles are congruent and the opposite sides are congruent, you have an isosceles triangle. So triangle ABC is isosceles. Definition of isosceles triangle. Of course, I didn't notice that this needed to be longer. I wonder if I just had it short so I can keep the assignment and the standard on the same page. Is probably it, so I wouldn't say, waste more paper. But I will see you probably, I've got to leave now. I'll see you in about a half hour in time for class. Have a good one.